welcome to another episode sa ating YouTube channel. And I noticed that a lot of you have learned so much when it comes to my discussion of videos back about sa average weighted mean. Kung paano nga ba natin kino-compute yung average weighted mean. So for this video, we will discuss ANOVA. So ANOVA is analysis of variance. So a video before this episode, I discussed the terms that you need to know before doing ANOVA. And I hope that in this video, you are already equipped kung ano nga ba yung mga terms na yon. Kasi sa video na to, makikita natin sila isa-isa. Okay, so let us start agad-agad using yung aking example sa last video. So here is my example for the last video. So I will read it once again. An experiment wants to determine the yields of 5 newly introduced varieties of corn using completely randomized design. So just a disclaimer, most especially in corn trials or corn research, ang ginagamit is RCPD. But for this problem, let's go for CRD muna. Yeah, kasi this is still a concept na it is the most basic experimental design. So let's go with CRD muna. So each type of corn is planted to 4 plots of land with equal fertility and grown under uniform cultural management practices, and yields in units of 100 bushels are shown. So yung mga numbers the numbers that you can see here in this table here, in that table, those numbers are the yields. 9, 8, 9, 10, those numbers are the yield. So one of the things that we need to note here is that there is an equal fertility and uniform cultural management practices. Thus, the experimental design, which is completely randomized design, works for this experiment. Because in CRD, there must be homogeneity of the experimental units. So here, merong equal fertility, and they are also grown under uniform cultural management practices. So the question is, can we conclude that the mean yields of the 5 varieties of corn are the same using 5% level of significance? So that question is just asking if there is no significant difference per variety. That question is asking if variety A is just the same with variety B, variety B is just the same with C, C and D, D and E, A and C, A and B, A and E, and so on and so forth. So that question is just asking if all of these 5 varieties have just the same yields after this experiment. So below here, you can see a familiar table. I think that I've already discussed that in my past video. And that table is also known as the ANOVA table. So we have our source of variation. I hope that you've already known the source of variation. What are the sources of variation for this experiment? The degrees of freedom, those are the formula for the degrees of freedom. We have the sum of squares, SS, then mean squares, then F computed, and F tabulated. So FC and F tab. So let us identify what are the source of variation, what are or is the source of variation for this example. So to explain that, I will already place here the answer for the ANOVA table. So the source of variation for this experiment is the corn varieties. Variety A, B, C, D, and E. So that's it. There you can notice the DF. Let us compute the DF using this formula. So T, when we say T, T is equal to treatments. And in this experiment, how many are the treatments? We have 1, 2, 3, 4, 5. We have 5 treatments, 5 different varieties of corn. Thus, the DF is T minus 1, 5 minus 1. That's why we came to 4 DF. Meanwhile, when we say N is a total number of units overall. So in this example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have N equals 20. Thus, if we will compute the total, N minus 1, that would be 20 minus 1. That is why we have 19 for the total. And for the experimental error, you will just have N minus T, N which is 20, minus T which is 5. That is why we have 15. So for clarity as well, treatments, we have 5, and N we have 20. So if you will substitute these values here in this formula, you will come up with these answers. So I hope that is clear for the DF. Maybe you are wondering why I am looking downwards. It's because I have here my iPad for me to, scribble on the slides. All right, so moving forward, let's go to the other components, SS, MS, FC, and FTAB. So I will use this. Yeah, so I will use this. So N, so here we can see that N is 5 times 4. 5 because we have 5 treatments. So we can also look at 5 treatments, which is this one. 1, 2, 3, 4, and 5. Then 4 plots or the replications. So that's 1, 2, 3, and 4. That's why N is the total number of experimental units. So we have N equals 5 times 4. That is why we came up with 20. Yeah. So for this, the first thing that we need to compute is CF. CF is also known as the correction factor. So CF is the correction factor. So to compute for the correction factor, you need to compute first this thing. So what you're gonna do is to add this one, 9 plus 8 plus 9 plus 10, and that would equate to this, 36, 15 plus 13 plus 16 plus 14, that will equate to this one. Then 9 plus 4 plus 4 plus 5, that will equate to 22, and so on and so forth. Then after having these totals, you will have a grand total, which is 184. You will add 36, add 58, add 22, add. So that's it. You will just add it until you come up with this grand total. So what you're gonna do there for the correction factor is that you're gonna square 184, which is the grand total. You're gonna square it and divide it to n, which is 20. We have already computed n a while back, right? This is n, and you're gonna divide the square of 184, or the grand total, divided by 20. That's why we have this value of 1692.8. So later you will know what is the relevance of this correction factor. All right, so moving forward, we have the total SS, or TSS, as we've discussed in the past video. So TSS is just the square of all the numbers in this table. As you can see in my handwritten computation here, wait, I will just delete everything. So as you can see in my handwritten computation here, I just squared every value. I just squared every value in this table, each one of them, and add all of those. So after I add all of those, here it is, yan. That's it. We will subtract the correction factor, which is we've computed in number 1, CF. So this equation will result to 1,958 minus the correction factor, which is 1692.8. That's how we will come up with a total SS of 265.2. So that is the total SS. So next, what we need to do is to calculate the treatment SS, or the TRSS. If we will go back to the previous slide, here it is. So TSS is here below total SS, while the TRSS is here. All right. So let me go back once again. So in order for us to compute for the TRSS, we need to get these values. And what we're gonna do is to square each one of it. So 36 squared, 58 squared, 22 squared, 44 squared, and 24 squared. And after that, you're going to divide it with t minus 1. That is the number of treatments, which is 5, minus 1. That's why we have 4 here. And subtract the correction factor once again. So if you will run it in your calculator, it would be 1914 minus 1692.8, which is the correction factor, and that will result to 221.2. So for the MSTR, because TRSS is here, right? So if you want to compute for the MSTR right away, you can do it. MSTR is this one, square of the treatment. So in order to do that, you're gonna have the TRSS and divided by t minus 1 again. So wait, MSTR, the equation for that is TRSS over t minus 1. So that is the equation for MSTR. That's why we come up with this 55.3. So that is 221.2 over 4. So that's it. So far, I hope that you are following. It will be helpful if you're gonna follow with me as I compute for this, this ANOVA table. So right now we already have this one that's already finished. We have already discussed SS for the treatment. We also have the total SS or TSS and the MS, which is 55.3 that we have just tackled just seconds ago. Right? So let's move on to the next, which is the error SS. So error SS will be, okay, the total SS, TSS, minus the TRSS. TSS minus TRSS. And then we learned from the previous slide that our total SS is 265.2 and our treatment SS is 221.2. So what you're gonna do here is to just subtract 265.2 minus 221.2 to have the error SS. So here we computed 44. And next, we're gonna compute for the MSE, mean square error. So for this, you're gonna get ESS, which is 44, and it would be divided to n minus p, which is 20. Remember, always remember this. One of the techniques that I want you to know when it comes to computing, manually, when it comes to ANOVA or any problem, is to write or note at the beginning all of the given. So n is 20 and the treatment is 5, and t is 5. So it would be easier for you to go with the flow along the computation. So here, n is 20 minus 5, so we will have 15. So 44 over 15, and we will arrive to 2.93 for the MSE. So that is already what's in here in our ANOVA table, 2.93. Now, let's move forward. Feel free to pause if you feel like this is a fast discussion or something. Feel free to pause this video or even, take a break or something. Yeah. So for the test of a hypothesis, we have also to compute. We need to compute for FC. This is the computed F value. Is the computed F value. So that is MSTR over MSE. So along the way in computing ANOVA, I suggest that you must have the table filled while you are computing. For example, here. So if we have not yet computed for FC, just place it here. Because FC would be MSTR, which is this 55.3, divided by 2.93, which is MSE. Right? That is our FC, F computed value. So you're just gonna divide this one to this one to arrive with that, with 18.87. So yeah, that is it. So now, after that, after you have computed everything, what do you need to do? It is to find the F tabulated. So F tabulated can be found in our F table. So this is F table. So in using the F table, you will be given with 2 DF, which is degrees of freedom. We have discussed this a while back. So here, our DF would be 4 and 15. DF1 would be 4, and DF2 is 15. 4 and 15. So that's our DF. Now let's go back to our F table. So our F table, we need to find DF1. So this is the values on this columns are DF1 and sa rows are DF2. So for DF1, you'll find 4, and DF2 you find 15. So if we're gonna trace that, we will arrive 4 and 15. We'll arrive at 3.0556. But before doing this, make sure that you are using the right F table, which is alpha at 0.05. That is actually mentioned in the problem. If we will go back Let's go back. So 5 varieties of corn are the same using 5% level of significance. So that is mentioned. And 0.05 is the level of significance that is usually used in computation. But it depends on the researcher then if they're gonna dictate if that would be 0.01 or 0.10. It depends on the researcher. But most of the time, researchers use 0.05. So that's it. The F tabulated would be 3.0556. And that is it, simply that. So let's go back here. Yeah, let's go back. Here. So we saw that the F tabulated is 3.0556 or simply 3.06 if you're gonna round off. So for that, we will have this decision rule. The decision rule is to reject HO if FC is greater than F tab. The question now, I hope that you have already learned this from my previous video, pero let's go back. The question now is, what is HO? HO is also known as the null hypothesis. When we say null hypothesis, this is the statement saying that there is no significant difference among treatments. So, null hypothesis, null hypo, no significant difference. No significant difference. Thus, this is somehow familiar to us because at the start of this video, I mentioned in the problems that the question is, can we conclude that the mean yields of the 5 varieties are the same using 5% level of significance? So this question is asking if they are all similar. And that is the null hypothesis, that they are similar, that there is no significant difference among these 5 varieties. So the decision rule for that is to reject that null hypothesis that there is no significant difference if FC, or the F calculated, this one, F computed, is greater than the F tabulated. And in this example, we can clearly see that the F calculated, which is 18.87, where is it? 18.87 is so much greater than the F tabulated, which is 3.06. That is why our decision is to reject HO. When we say we reject the HO, we say that those 5 varieties of corn are different from each other. At least one of those 5 varieties is different from another. That's our decision when we reject HO. So thus, our conclusion here is at 5%, at least one corn variety gives a different mean yield. Yeah, so that is pretty much it for the computation of manual computation of ANOVA group. So I thank you very much for your time, and I hope that you have learned so much from this video. If you have any questions or everything, you can just comment it below, or you can message me through my email, sproutupi6111@gmail.com. So that is it. Thank you very much.